Hi, and welcome to this walkthrough of an applied Gibbs equation question. So it gives you the Gibbs equation at the top of the question, up here. It also gives you a plot of delta G against T. It asks you to say what's significant about the gradient of the line and the values P and Q as shown in figure 18.1, which is obviously our plot. So looking at the plot, first of all, you can see it's a straight line, and therefore that means that if it's connected to delta G equals delta H minus T delta S, that must mean that Y equals mx plus C is the analogy to this. So because it's a straight line graph, clearly you can use Y equals mx plus C to describe it as well. So connecting those two together is your first piece of reasoning, so you can put that down in your answer. The next thing to look at is the y-intercept. So at the y-intercept, the value for x is obviously 0. So therefore the value for t is going to be 0. So therefore the value for minus t delta s will also be 0. So from this we can surmise that p must be equal to delta h. The next thing to think about is the intercept through the x-axis. So in other words, point Q. So if you look at the gradient, it's obviously a positive gradient going from left to right. It slopes upwards. And what's also happening is, if that's equivalent to minus delta S, that must mean the actual delta S, in other words the change in entropy, must be negative. So as the positive gradient is equivalent to minus delta S itself must be negative value. So what does this mean? Well, as the temperature increases, as we go from left to right, what happens to delta G? That starts to become more positive. It creeps up towards 0 and then becomes more positive. So it must mean that as the temperature increases, then the entropy goes down, delta G becomes more positive, the reaction becomes less feasible. So Q must be the boundary, the temperature at which feasibility changes. So just moving on a little bit from what I said a moment ago, in the area that's shaded blue to the right of point Q, the values for delta G are positive because they sit above 0, 0 on the y-axis. So they're equivalent to these values here. So the reaction won't be feasible at these temperatures. If you move to the left of point Q, following the line, here the values for delta G are negative, so it will be feasible at these temperatures. So what this must mean is this reaction, as you increase temperature, must get less and less feasible. So what is it that they want from you in the question? Let's have a look at the mark scheme. They want a link to y equals mx plus c. They want the gradient as minus delta s. No particular conclusions from that. And they want P equaling the enthalpy change as delta H. And Q must be the temperature at which feasibility changes. Okay, thanks for listening, and until next time, see you soon.